Hello, my name's Joanna Endter-Wada, and I'm a faculty member in the Department of Environment and Society in the Quinney College of Natural Resources at Utah State University. The title of today's talk is Water Demand for Urban Areas. The U.S. West has some of the largest and fastest growing cities and urban areas in the country, despite the fact that the region is generally arid, subject to droughts, and increasingly vulnerable to the effects of climate change. So understanding urban water use is an important component of the story of water in the U.S. West. Today we're going to go through 5 questions in order to better understand urban water demand. The first question is, what is the nature of urban water demand? Urban water demand is generally defined by sectors. Those sectors are most often categorized as residential, commercial, industrial, and institutional. In addition to characterizing water use by sector, we can characterize it as indoor water use and outdoor water use. So characterizing water use by sector and also as indoor or outdoor use is very important for helping us to determine our water needs and wants, and also for debating and prioritizing uses in times of scarcity. So our second question, how does water demand fit into urban water management? The traditional approach to managing water for urban areas was a supply-side approach. This focused on securing water from distant locations and bringing it to places where people chose to live. This involved constructing engineered infrastructure, dams, pipelines, and treatment plants to move water from rural locations oftentimes to urban areas. The supply-side approach has been generally very successful in providing convenient, easily accessible, inexpensive water so that most people in urban areas don't really know where their water comes from, how much they use, or even how much they pay for it. But water supplies in the West are becoming increasingly scarce, and they're being asked to meet many different needs. So urban areas and water managers are increasingly focused on demand-side management. Demand-side approach focuses more on the end uses of water, on people's expectations and habits related to water. All of these are approaches attempting to gain greater efficiencies with existing supplies, to stretch water further, and to help conserve it. A demand-side approach relies much more on understanding human behavior and on the policy, economic, and social sciences instead of as much on engineering. So our third question here, what factors influence and shape urban water demand? Fundamentally, human decisions and the behaviors associated with them shape urban water demand. There are many kinds of decisions that we make individually or collectively, decisions that have short-term as well as long-term consequences. So here's some types of decisions that shape urban water demand. Public policy and planning decisions are important. They help decide where new development will go, the forms that new development will take. They can include landscape ordinances and building codes that have different effects on water use. Commercial decisions are also very important. The places that they locate, the buildings that they use, the products that they produce and sell to others has a great influence on urban water demand and on the decisions of people who are their customers. Landscaping decisions are particularly important. In the United States West, approximately 60 to 75%, depending on where you are, of urban water is used on outdoor landscapes. And so the plants that are used there, the irrigation technologies used to irrigate those plants have a great influence on shaping urban water demand. Institutional decisions are important for the reason that they affect the decisions of many other people. Homeowner associations and condominiums, for instance, might have landscaping ordinances that influence all the homeowners that live within their boundaries. Government institutions can make decisions that affect all of their buildings or all of the properties that they manage. Consumer decisions, finally, are very important. Where people choose to live, the kinds of appliances they choose to buy, and how much water they choose to use and to pay for is a big factor in urban water demand. So here's our fourth question. What are some of the tools for managing urban water demand? Water demand science and practice is evolving rapidly in the West, and there are many examples of cities that have been successful at reducing overall consumption of water, even in the face of growing populations and economies. Here's one example of Seattle, where they've had great conservation success in a chart related to tracking their use over time. But other cities have done the same. And they've done this through a number of different approaches that have promoted greater efficiency and conservation of water. The strategies that they've used are generally designed to inform and motivate and encourage people to make different water decisions and engage in different behaviors and invest differently. A lot of these approaches are voluntary in nature. These would include things such as public education campaigns that raise their awareness of shortages, technical information and assistance that helps them to act on their motivations to conserve when they might not know how to do so. And rebates and financial incentive programs are offered oftentimes to help people upgrade their existing infrastructure in their homes, their facilities. In addition to voluntary approaches, though, mandatory approaches are often used, especially in times of scarcity. Building codes, landscaping ordinances, and different types of water rates and how they're structured, as well as watering restrictions, are examples of mandatory approaches. One particularly effective mandatory approach was federal legislation that mandated water use efficiency standards for indoor appliances and fixtures. Greater efficiency is not as easily engineered in outdoor water use. The efficiency there is a result, oftentimes, of a fairly complex intersection between human behaviors and the plant materials people have in their landscapes, the irrigation technologies they use to water those landscapes and their sophistication at using those technologies, as well as site features and landscape designs that may make it easier to be efficient. All of these occur in the context of dynamic climate variability. So promoting outdoor water use efficiency requires contextualized systems thinking and understanding human linkages to landscape water. One way to promote outdoor landscape water use efficiency is to install or transition to low water use plant material when and where that's appropriate. But a lot of savings can be gained just on existing landscapes with helping people to irrigate them more efficiently, with new tools and information related to how best to install and maintain and operate irrigation systems for greater efficiency. Water agencies are also transitioning to new technologies to more effectively manage urban water demand. They're installing automated meter reading equipment, advanced metering infrastructure. All of those support greater sophistication in the analysis of urban water use patterns. Here's one example of such a tool, one that we've been working on here at Utah State University, called Water Maps, Water Management Analysis and Planning Software. And it's designed to analyze residential water use across a whole service area by calculating landscape irrigation ratios that compare water used on landscapes to the water that's needed on those landscapes, and then to benchmark that use into different categories to give people the signals as to how acceptable or efficient or perhaps inefficient their water use is. This last question addresses the important issue of the purposes and potential consequences of promoting urban water demand management in cities in the West. There are a number of different conundrums related to promoting water conservation in urban areas. And these include a number of different things, such as the economics and politics of Western water that pressure cities to develop and use water that they're legally entitled to before others develop that water and create dependencies upon it. Water demand hardening refers to the phenomena of securing long-term water efficiencies, but then having greater difficulty responding to short-term shortages such as drought. Another conundrum is that utilities often have disincentives due to their long-term contracts for water delivery and loan repayments on their existing water infrastructure. And they're forced to sell water in order to meet the financial obligations that go with those contracts and those loans. In addition, sometimes there are water dependencies that have been created through the current inefficiencies, sort of ecological dependencies and hydrologic independencies downstream or in aquifers underneath cities. And finally, there's the conundrum associated with the water energy nexus. And a lot of research is going on right now to try to understand urban heat islands and the role that green vegetation in cities plays in mitigating that. Despite the conundrums that individual cities and water utilities face, recognizing regional water scarcity and setting priorities on its use is one of the most important challenges that we currently face in the West. Conservation plays a key foundational role in effectively managing urban water. That's a large and growing part of the use in this region. Conservation is an approach that has to be utilized in connection with optimization and the repair and replacement and design of existing infrastructure, and in some instances, development of new supplies. But it's important that these be sequenced and prioritized and that there are synergies found between them. We are in an era where the infrastructure that was installed during the supply side period is aging and in need of replacement. And as we do that, we can find ways to conserve and optimize for greater efficiency. Pursuing new supply side options risks additional impacts to rural areas and the environment and tribal homelands. But similarly, pursuing water demand management to fuel urban growth is not a viable long-term water sustainability strategy. So we need to pay attention not just to the efficiencies, but also to the equity issues involved in managing water in the West. Urban water demand is shaped by the decisions that we make. We can decide to restructure the rules and incentives for managing Western water resources in order to overcome the conundrums. We can decide to manage urban water on a more equitable basis, so one location's saved water does not enable another location to waste it and create disincentives for conservation. We can decide to respond collectively to the shared vulnerabilities of living with aridity and responding to drought and adapting to climate change. We have decisions that we can make that will influence the future. So the decisions we make today will leave legacies, water legacies for future generations. But we have choices to make, and that's part of what you will be exploring throughout the rest of this class. Thank you very much, and I hope you enjoy the rest of this course.